AI-generated influencer has been a big topic last year. There were companies literally built for launching different AI Instagram models who looks just like people and will post their lifestyle on Instagram. And those people looks absolutely real, except they don't really exist in real world. Or I should say they do exist, but more likely to be a male prompt engineer controlling all those different AI models instead of a real girl. And some of them are clearly fake and AI generated, but still got 20K, 80K, or even more than 100K followers on Twitter. And probably it's generating some sort of revenue too. So even though I don't really get why people want to follow someone who they know is not real, but there are clearly demands. So I've been thinking about what kind of actual business value or use case that could exist for those AI models. And recently, my brother-in-law reached out. So he is running a small business in China to sell clothes online. And he asked me, can you get AI to create 20 or 30 different social posts of people wearing my clothes every day? And this sounds bizarre to me at the beginning, like why do you need so many new posts every day? Then he told me the reason he needs so many different new posts every day is because for people who are buying things online in China, they will go to social media platform like Redbook to find other people who also bought similar product and see their review and pictures. If someone search for the clothes that he is selling, then the customer will gain more confidence that this product is probably a good fit. So I don't really know whether his brilliant strategy actually going to work out. And I personally don't really like the idea of AI generated social media posts. But I do think AI powered model for fashion and clothes is going to be very valuable. It can help people visualize how the clothes going to look like much better than a static image. And those e-commerce sites can just generate a huge amount of product image for different type of customers. That's why for the past few days, I looked into image generation and build an agent that can actually mix match different face, clothes, and even post-trend environment together into popular social media posts for those fashion brands. And I'm going to show you how to do it because image generation is actually a lot of fun. Before we dive into the implementation, probably it would be useful to understand how does AI image generation works and how can we add more control to the image generation process. To use AI to generate images, we normally will use model like Stable Diffusion or DALL-E. What this model do is they will be able to turn a noise static image into a high fidelity image of what we want. But how does it actually work? The way it works is actually pretty smart and interesting. So even though turning a random noise image to a high fidelity image in one go is really hard, but when you break them down into small tasks, it seems much more manageable if you want to take this image, denoise a little bit, and to the next state. All we need to do is train an AI model that it is really good at identify the amount of noise to remove between those images. Then it can break this stunning task into small tasks and complete it iteratively. So to train such an AI model, what we need to do is have a huge amount of image data. And for each image, we will need to add multiple levels of noise into this image based on schedule. Then we can use those data to train the AI model to denoise in the reverse way. We can give this AI model a random noise image like this and tell it this is a fully noised image of a cute cat. Now, I'm not going to ask you to generate the original image, but try to figure out what's the amount of noise that we need to remove to, let's say, get to the next 5 frames of less noisy image of this cute cat. The model will be able to guess the amount of noise to remove and detract those noise. And you will get something like this, which is still a lot of noise and not very clear what it is, and most likely not perfect. But what we will do next is we will add a little bit more noise to this new image and put it back to do this process again. Well, this time we will tell the model that, okay, this is image of t-1. Now try to guess what's the amount of noise that we should reduce to get to t-6. And it will get a new image, still not perfect, but probably a little bit closer than what it was before. And it will repeat this process again and again until we got a high fidelity image. And this, in a nutshell, is how the diffusion model works. It's basically a process of denoise the image. But you might have a question, how does the AI model knows what does a cute cat means? Because these two images fundamentally are just a bunch of pixels to the AI model. That is done through the process called tokenization. Basically, for every image in the training data set, we'll provide some caption and description of the image. Like the one on the left is an animal, cat, cute, and brown eyes, versus the one on the right is like a male, old, and blue eyes. Each one of those captions is almost like a way of measure and classify the image, which we can use to understand the relationship between the image as well as the text. Each of the image data can be plotted on a space like this. So the next time when we have a text prompt like a cute cat, we will know where does the final image stay in this latent space and use that as a signal for the AI model to understand, am I generating the image in the right direction? Except it is not a simple 2x2 measurements. There have thousands of different dimensions. Eventually generate really complex latent space that can connect the different image and text together in terms of semantic relationship. And this requires huge amount of training data. But luckily, there are already open source models that we can use. The most popular one is the openai clip model. With this model, when the user gives a text prompt like cute cat, it will automatically convert this text into a specific position in this latent space so that we will know where does the final image sit in terms of this latent space. And we will use this as a signal when the AI model is trying to denoise image to make sure it is generating image in the right direction. I know I have talked a lot of concepts so far. Let's just try to create an image with these AI models. To do that, we're going to use ComfyUI. So ComfyUI is an open source project that allows you to build very complex and flexible image generation pipeline. So you can run all sorts of different image generation model on your computer directly. And the best part is you will be able to export the workflow into the JSON format and host that image generation workflow somewhere so that you can generate the same image next time. There are even hosts that replicate that allow you to just copy paste the whole workflow in and start generating the image on their powerful GPUs. If you're using Windows, you can just go to the Comfy Hub and there should be a download link there. But if you're using Mac, you just clone the repo and install manually based on the instruction here. So I'm using Windows here because I do need to use the GPU. Once the installation is done, you can just open the folder. There should be two scripts. One is CPU, another is the GPU. If you do have NVIDIA GPU, you can just double click. Otherwise, you can use CPU instead. You will see an interface like this. So at default, it is using V1.5 model. And that is basically the stable diffusion V1.5 model. You just go to this Hugging Face link I have put in the description below and click download and put this downloaded file into ComfyUI models folder and checkpoints. So once you put this in, you should be able to run it. And we can just connect everything together, which is where we put the negative and positive text prompt and add a k-sampler. Each image generation here is called a sampling. So k-sampler is basically used to generate the actual image. It will be in the latent space. We're going to use VAE decode. So this will basically turn the latent into actual image. So we give it a try. Text prompt to be a woman wear a blue jacket. And we can click on this Q prompt. Okay, now you can see an image generated, but how can we actually create an image with our own AI model face, clothes, as well as specific environmental posture that we want the model to have? And to achieve that, there are a couple of ways. Assuming if you already have an image, one easy way is integrate new elements, which is like clothes, into existing photos. So this is useful if you already have some good model image that you want to use, but you just want to replace the clothes to be your own clothes. There are a couple quite mature models that you can use right away. One is a model created by Alibaba called AnyDoor. It is basically a model that allows you to integrate a new item into existing image. I can upload the original image and by just masking the object that I want to change, and then it will generate a new image that replaces the original husky dog into this toy dog. And same concept, I can upload the image of a model as well as new clothes. I can just mask a clothes area in the original photo, and this will generate a new image with the same model but different clothes. On the other hand, you can also use model like OD diffusion, which is a model that's specifically designed for those outfitting fashion-based latent diffusion. And this model is live on platform like Replicate, which means you can call out IPAdapter. And the way it works is that you can upload it, then just upload an image of any clothes that you want the model to try on. Then it will be able to generate a new image with this new clothes. For example, I can upload image that is not in this kind of wide background setup, and then upload a random clothes image. And then it just generates a new image of this fashion looking guy, but wearing a kind of security type of uniform, which looks funny. So you can probably build some kind of interesting application that your user can just take a photo of themselves, upload it and just choose any clothes. And then you can call this API on Replicate to upload both the customer's photo as well as the photo of the clothes to remix them together. It should be pretty easy to use. So in your use case, if you already have a photo, you just want to swap the clothes, I definitely recommend go use this OTT diffusion. I have put the link in the description below so you can check out. But in our case, I actually want to create a fully customizable AI model where I can generate the face of the AI model from scratch and give it any clothes and even give it a certain environment so that it can create a very original photo that can be used for social media posts. And to do that, there are a couple of ways. One is that you can fine-tune your own model, so you can collect a lot of photos of the same person, fine-tune the model with those data. So the next time when you get a prompt, it will be able to generate the same face. And thanks to techniques like LoRa, the cost of fine-tuning has been dropped a lot. But still, you do need a good amount of training data to be able to do this LoRa fine-tuning. But on the other hand, there's another method that is developed by Tencent called IPAdapter. This has been an extremely lightweight solution for you to insert certain elements of some photo reference into the image generation model. The good part of using this method is that it doesn't require a big amount of training data. All you need is just one photo to be able to generate a new photo based on a specific face. So the way it works is that you can give it a photo of a person's face or a specific clothes. Then we can encode this image and mix together with the text prompt you give and use them as a final prompt that we're going to send to the image generation model. And if you want to generate image with specific face and specific clothes, we can just chain two different IPAdapter together, which should generate the final image with both elements considered. And you can build the whole image generation pipeline with IPAdapter in the ComfyUI. And I'm going to show you how you can do that. Before we start, we need to install something called ComfyUI Manager. So this allows you to install and manage custom nodes and additional functionalities. To install that, we can go to the ComfyUI folder, right click and open in terminal. Then we'll cd ComfyUI and then do git clone of this hub repo. And that's pretty much it. You can just restart the ComfyUI. Then your new called manager. Click on that. It will give you this new UI button called custom. And you just search for any nodes that you want to use. And firstly, we need to install a few custom nodes. So I'll click on this button and let's firstly search for IPAdapter. And we can install the ID 91. So this will give you the IPAdapter nodes. And next we will search for impact. And we will need to install number 2, which will give you a few different custom nodes that you can use for IPAdapter as well. And after that, we will search for control. And the number 6 is the one that we're going to use. So this will give us new nodes for control net, which is something that we can use for additional control, like control the posture of the AI model. And after that, we also need to install the model. So one model we're going to use is Clip Vision. So if you search for Clip Vision, this is the one we're going to use called Clip Bit 14 B7. So this is basically the model that we're going to use to tokenize an image so that we can use as additional signal when the AI model generate image. And we can turn certain image like face or clothes into token that can be used when generating the image. And that's pretty much it for the custom nodes. And to run this, we will also need to actually download IPAdapter model. So you can go to Hugging Face, which I post a link in the description below for the IPAdapter Face ID. And depends on which model you're using. If you're using the Stable Diffusion 1.5 model, then you can download this 2 file. But if you're using the Stable Diffusion XL, which is I'm using, then you can download this 2 file. On the other hand, there's also a second link, which has this 2 folder. Under the models folder is where you need to get everything you need if you're using Stable Diffusion 1.5 model. But again, in my case, I'm using the Stable Diffusion XL models. So I'll click inside this model and we need to download 2 files. One is this one, IPAdapter plus face. Another is this one, IPAdapter plus. And that's pretty much all the essential models that we're going to use. After downloading, you can open the ComfyUI folder and go into the models folder. And inside here, this is where you're going to put all the different models for different purpose. So I first search for the LoRa folder and putting the IPAdapter face to SDXL LoRa. Basically put the file that has a name LoRa inside into this folder. And the rest you need to put it under the IPAdapter folder. And if you don't have this folder, you can just create this folder and put the rest of file here. And last bit, if you just create IPAdapter folder, you will need to open extra model path.yaml file and then add this IPAdapter folder here. And that's pretty much it. We can start building. And the last is that we actually want to download some fine-tuned Stable Diffusion model that is particularly fine-tuned for generating like human face, for example, or more realistic photorealistic image. And the one plan to use is the one called Realism Engine SDXL, which is a model that's specifically fine-tuned for generate photorealistic image. And you can download this model for free on Civitai. And on this website, there are a huge amount of different models actually. So you can actually go find a different model that fits your needs better. But for the specific demo purpose, I will use this model. And after you download this model, again, you will put that model into one of the folder in this models folder, which is checkpoints. And here's where I put this Realism Engine SDX. So that's pretty much it. We can start building our own AI model. If I go back to ComfyUI, I can double click and add a checkpoint. So load checkpoint. I can select the model I'm using, which is Realism Engine SDXL. And then I will add the clip, one for positive prompt, and connect the clip together. and also search for the case and connect the different prompt together as well as model. And I will add a empty latent image to configure the size of image. Because I'm using the SDXL model, I will change the width and height to 1024. But if you're using the 1.5 model, you can keep it at 512. Connect the latent to latent image. Then I will need to add a new node called VAE decode. So this will actually decode the latent we generated into the actual image. And we can preview the image. And I will also change some configuration here. So I will increase the step to 35. So generally, the more step you have, probably you give the AI model more time to actually generate things, so better quality. And I'm going to change the sampler name to be DPM P2M, and as well as scheduler to be Keras. So sampler name and scheduler basically is some additional configuration for you to control how does that denoise process look like. For example, should it just add the same amount of noise every time? Or should it at the beginning, it try to denoise a very iterative step, but gradually ramp up in the end when the image is more clear. So there are different configurations, but this DPM P2M plus Keras is pretty popular configuration. So all we need to do is just add some prompt that can be used for generating a AI model curve. And this is one pair prompt that I learned from another YouTuber called Data Leveling. He has a lot of good content about ComfyUI. So I definitely recommend and go check it out if you want to dive deeper. But this is a set of prompt that has been worked pretty well for me in terms of generating human face. So now we can just give it a try by click on this Q prompt. Okay, great. So now you can see it actually generated a AI model face. If you want, you can change the prompt a little bit and you generate a new face again. Set this, and because I set a control after generate as fixed, that means if I click on again, it will just keep reusing the same image. Okay, great. And after that, I will just control and select all the nodes. And in the empty space, right click, add a group for selected nodes, generate AI model face. Click OK. The next thing we want to do is that I want to actually create a IPAdapter face ID based on this face that we generated. And to do that, I will firstly add a node, is few star, called prepare image for inside face. And I will connect this image to this node. And next is I also want to create a mask of this image. So if I search for segment, I can choose this one with segmenter called Coco segmenter and connect this image to this one and change the resolution to be 1024. And I will try to preview the image and another node called convert image to mask. And then I will add a new node called apply IPAdapter face ID. So I can connect image as well as a mask here. I will load IPAdapter model. In here, I will choose the face ID plus and connect IPAdapter. And we're going to use a clip model that we downloaded earlier. And for the inside face, I'll just choose CPU here. And the model, I will reuse the model that we have earlier. And I will change the configure a little bit. The weight, I will change to 0.5 because we're going to connect a few more IPAdapter together. Face ID V2 turn to true and weight will be 1.5. And this time will be apply IPAdapter versus previously is I apply IPAdapter face ID. And I will load IPAdapter. The previous one is face ID, but this one will be plus face. Connect this together. The model will be the model output we got from the IPAdapter face ID. And the mask going to be the same. This should actually generate a new image based on the same face with IPAdapter. So we can quickly add two clips for the both negative and positive text prompt. And we're going to add a new sampler to add the positive, negative, the model output from the IPAdapter, the latent image setup 41024. And again, we will decode the image and connect the VAE that we have for the original model. And in the end, let's preview the image. Oh, I forgot. I need to add a clip from the previous checkpoint. So let's run again. And the first time it will take a bit longer because we are loading all those models. But after the first time, it should be much faster. Okay, cool. So we got a new image. The result is not that great. And the reason is, I believe, two things. One is that I probably will need to add some prompt to give it more instruction. Second is that I think I forgot to change the weight for the second IPAdapter here. Generally, you can change something between 0.2 to 0.3. And again, for the case sampler here, we can change the setting here to make it better. And now let's try again. Okay, cool. Now you can see this new version looks much better and also very close to what our original face look like. You can also give some additional prompt to change the background or environment. So we can change this to be cafe. And then you can see the image now has transformed to a cafe with similar face. And you might notice there are some parts like eyes don't look exactly correct, but don't need to worry. Just use the upscaler to improve those details. So this seemed to working pretty good. So next thing we want to do is we actually want this model to wear the clothes that we wanted to try on. And the way we're going to do that is we're going to create another IP adapter. We're going to connect to this time. So I can firstly load the image. I can add one image in and then do the same. So I'll search for a segment. This time I'm going to use a uniformer segmenter, which I just found works better for those close image. Then load adapter model. And this time I'm going to use general IP adapter plus model. And then connect this IP adapter. The clip vision model, we can reuse the same one. The image will be the image of the mask will be the one we have here. And the model will be the model we have here from the previous IP adapter that already has the face as part of weight. You can just add a preview of the image to see what does the mask look like. And the weight here, I'm going to change to 0.5. And I'm going to connect this new model to our sampler instead of using the previous model. Also give it a bit more detailed prompt, wear a blue jacket, and try again. Okay, this time you can see that it generates a image. It's very close to the image that we were given. Yeah, so it almost looks identical, which is pretty good. The only thing is that the color of the girl's hair is not that blue now. So I probably just add the prompt a little bit. So woman with blue hair, wear blue jacket, and try again. And also I changed the image resolution here to be 1024 to match the same size. Okay, cool. So now you can see this new image is much closer to what we want. It's both the right face as well as the right clothes. And you can start changing the environment as well. So I can add the prompt in a cafe and try again. Okay, yeah, you can see now it actually changed the background to be a cafe. And you can just change the prompt to generate the actual image you want. So this is a quick example of how you can create a workflow with ComfyUI and different model like IPAdapter to build your own image generation pipeline. So now, since we already built a proper image generation pipeline, the next is we want to export this workflow somewhere so that you can either load it again later, but also deploy online on platform like Replicate, where you can just turn this workflow you built into an API service so that you or other people can just call and get the quality image back on a high performance GPU, which means it should be much faster and production ready. To deploy your ComfyUI workflow, you can even build an agent system where it connects a few other AI models together to improve the image quality. For example, the agent can call another AI model that is specifically designed to fix hand distortion, where I might have initial image that have 6 or 7 fingers, which is a very typical problem, but it can just fix this part. And after all those things are fixed, the agent can call an upscaler to turn the image into high fidelity and fix a lot of small issues. The eye still feels a little bit artificial, but after the upscaler, it will feel much high fidelity. So the first step is let's deploy a ComfyUI workflow on those hosted service. We do need to make some slight change on our workflow because on Replicate, they support specific models and custom nodes. For example, the IPAdapter custom node they are using is slightly different from the one we are using. And also the AI model we originally using are in the supported wait list. So we will need to find the alternative model that they support. And I'm going to use the Juggernaut. So to do that, I will firstly go back to my ComfyUI. I will need to remove some custom node that they don't really support. The one that we're going to remove is called prepare image for inside face. So this custom node is not really available in the version they're using. So I'm going to remove it and then just use original image instead. So that's pretty much it. I can click on this save button and this will save this workflow into a JSON format that you can load later in another ComfyUI. But the one we're going to use today is called a save API format. If you don't have this option show up, you will need to click on setting button. There should be an enable dev mode option. So you need to check this one. And then you should have the save API format option. So if you click on that and then you save the API, then you should have a JSON look like this. And what do we need to do? I will need to change the model to a model that they support. And I'm going to use this model instead. So I can just copy this and paste it in. Currently in our ComfyUI, it does take an image of a clothes and we want to swap it with a image URL instead to make it easier. So I'm going to search for load image. So this is what we have currently is point to a local image file. And I'm going to replace this with an image instead. So I can save this. Once you finish that, you can just copy this and then go any UI workflow project on Replicate and paste in your JSON file here and click run. So now you can see it actually generate image on Replicate instead. Total time is around 2 minutes, which was way faster when I was running on my local machine with a 3080 graphic card. It is also scalable because I can call this API for multiple times. One thing you will know that some part of this close is still not 100% matched with the original close image because we're going to fix that through an agent system. So we're going to build a multi-agent system where it has two stages of tasks. The stage one is image generation. So image generated, who are able to call the ComfyUI workflow that we host on Replicate to get the original image based on text prompt. Then it will pass on to image reviewer, who will compare the AI image with the original close image to find a 100% match. If not, give feedback about how to iterate image. It can go through multiple iterations by itself until a point where the close in the AI generated image is almost 100% close to what the original one. It will pass on this image to the second stage where we will have an image enhancer agent who are able to call all sorts of different specialized AI model on Replicate, for example, for fixing the hands or upscale image into high quality ones. So this process actually feels a bit complicated because it has multiple stages of agent tasks. We need to figure out a way to passing on the context. But thanks to framework like autogen, made those complex multi-agent structure fairly easy, where they provide a lot of useful feature where we can set up very complex agent collaboration workflow and also passing on the context between different agent groups. So I'm going to show you how can you create this agent system with autogen in just 10 minutes. Let's get it. Firstly, let's open a folder in your Visual Studio Code and we'll create a few files. This is where we're going to store all the credentials for openai API as well as the Replicate API token. We'll create a tools.py, and this is where we store all the functions and tools that agent going to use to generate image, review image, fix hand and upscale images. And lastly, I will create a main.py, and this is where we're going to define all the different agents that we're going to use, register the function that we just created in tools.py to those agents, and in the end, create different group chat and trigger this agent workflow. So that's pretty much it. Let's firstly go to tools.py and create those functions that we're going to use. I'll firstly import a few different libraries and also run load.env, which will read the credential that we store in .env file. I will firstly create a generate image function. And this is basically a function that will call the ComfyUI workflow that we host on Replicate and get the image back. And to do that, you can create an account on Replicate. They will give you some free credits. If you're just running small experiment, you can just use it for free. Firstly, we need to go to the Replicate any ComfyUI workflow. So if I search for ComfyUI, there's one called FOFR/any ComfyUI workflow. So I can click on that. This will take you to this interface. You can click on Python. So you will first need to run pip install replicate. So if you haven't done that, you can open the terminal and pip install replicate. You can skip this part because we already put replicate API and just copy your API into the .env file. Then we will import replicate and just run this model. In here, we basically just select the specific replicate project, which is any ComfyUI workflow, and passing on the whole workflow JSON. Then it will return the result for us. If I go back here, I basically created a function called generate image, where it would take firstly the original close image URL as well as the text prompt. And then I copy the whole JSON file of the ComfyUI workflow. And I basically change two parts. One is for the positive prompt. I replace it with a prompt variable that we pass on here to the function. And for the original close image URL, I basically go to load image node and replace image file URL to be the original close image URL that we're going to pass on here. The rest you can just keep the same. We will stringify the JSON and then run the replicate model by passing on this workflow JSON. And then I will return this final result where I include the original close image URL, the text prompt, as well as the AI generate image. So we should be able to just call this function by passing on the close image URL as well as text prompt. And then it will return the image array. That's pretty much for the first function. And then the second function for review image. So we want to create a tool that can call the GPT-4v model by passing on the original close image URL, as well as the image generated by AI and text prompt. It can compare this to image and find if there's any mismatch between those images. So inside, we're basically called openai GPT-4v vision model. By passing on some message from user, I will give a prompt that first image is the image of clothes, second image is the AI generated image of people wearing this clothes. Please compare and classify if the clothes in the second image are around 95% match the first image, 95% match, just return 95% match. If less than 95% match, then list out and iterate the original text prompt for the image generated model to fill the gap. And then I ask to return the specific format. Then I will pass on the two images, return a report about the comparison. And in the end, we're going to create one function for fix the hands. And again, just pass on the final image generated by AI and the replicate model called hands restoration. You can search on replicate and here. I test a few. This one seems to be the one that works best. And we're just passing an input file. And same thing for the function of upscale image. So we will call another replicate model portrait upscale. If you search on replicate, you should be able to see this ultimate portrait upscale, and then copy the code example here. Be sure you change the image URL as well as text prompt to be the one that we use in ComfyUI. So that's pretty much all the function that you will need to get agent running. And now we can switch back to main.py to actually set up agents. And similar things, I will first import a few different libraries that we're going to use. Then I'll create agents that we're going to need. Firstly is image generator agent. So I'll do image generator equal conversable agent. Name is image generator. The system message is you are world-class AI image prompt engineer. You will be given an image of close and text prompt. With information given, you will continuously iterate image based on feedback from image reviewer until the image reviewer is satisfied with the result. And I will passing on large language model config as well. I'm using GPT-4 Turbo Preview version. The second agent is image reviewer. So this agent that is responsible to review both original close image as well as image generated by image generator. So it needs to classify if close in the image from image generator is 95% match with original close image. If it is, then return this. If not, just keep iterating the text prompt. And I have this language model config and also have its termination message to be 95% match. So this is basically a feature that autogen has, which means if the message from this agent, including things like 95% match, then the task should be considered as completed. And the last one is the image fine tuner. So this is the image enhancer agent that improves the final image. And again, we're passing on the same large language model config and termination message. At the end, I will create a user proxy agent. This special agent in autogen who is representing the user and do things like running all those different functions and code execution. We will basically do the similar things and set human input mode to be never, which means it will just auto run by itself. So this is basically all the agent that we need. We need to register function that we're creating tools of PY to the relevant agents. So at the top, we'll do form tools, import generate image, fix hands, upscale image, and review image. And then we'll register those functions one by one. So I'll firstly register the generate image function. Here you can see I define the caller and executor. So in autogen, you can basically define which agent will actually decide the function to use and which agent will actually do the execution. Executor is user proxy agent. I will define the caller to be image generator, give a name and description. And same thing for the review image, as well as fixed hand and upscale image. And that's pretty much it. All we need to do now is just create a group chat to connect everything together. So I can create a group chat, which has the image generator and image reviewer, which will represent the first part of task, the image generation. I put max round to be 7 because I sometimes observe that it can continuously running the agent multiple times. Then I will set a group chat manager. So group chat will be called after every single step, and it will decide what's the next agent to be called based on the chat history. That's why it also needs a large language model config, where I'm giving it a GPT-4. In the end, I'm going to passing on the closed image. So this time I'm choosing a different closed image like this. And then I will initiate the chat by doing user proxy.initiate chats. So here is where we define the workflow. It will firstly call the group chat by sending a message to recipient group chat manager. And with the message, this original close is base prompt. Now generate a hyper-realistic photo based on original image as well as base prompt that pass 95% match from image reviewer. I will also define the summary method. So summary method is part that you can control to decide what context to pass on from task 1 to task 2. At the default, it has two options, reflection with large language model or last message. And at default, it is last message, which means it basically will take a last message as context and pass on to the next agent. But in here, I'll select reflection with large language model. And what it does, it will try to summarize whole agent conversation. And you can actually pass on the summary prompt as well to dictate what are specific format or context information to be extracted. And here I will say, including the latest AI image URL, as well as original close image, latest prompt, so that it can pass on the 3 key information to the image fine tuner. And the image fine tuner will have this prompt that fine tune the latest image, fixing hand distortion if there's any, and then upscale the image that returned from fixed hand to make it high quality. So that's pretty much it. We get this agent system working already. I can open the terminal and do Python main.py. So now we get the result and let's review it. First of all, the version of autogen I'm using has some weird bug that it has those noise message in the chat history, but we can ignore for now. So the way it works is that firstly, the user passing on this task to the agent, and then the group chat manager delegate a task to image generator first, who calls generate image function by passing on the original close image. And I just give a very simple base prompt that it is wearing a blue clothes in cafe in Paris. And then it starts generating an image. And the first image it generated, as you can see here, the clothes here is nothing like the clothes that we want, but it is fine because we're going to have an agent to review this image and provide feedback. So the image reviews this image and give feedback that the first image is a blue padded jacket with visible stitches lines. And second image is more like draped garment rather than a jacket. Then it gives a iterated prompt. A woman with blue hair wearing a child-sized blue padded jacket similar to the one in reference image provided. We might need to change the function a little bit to making sure it didn't really include things like reference image because it won't really help. But that's fine. Let's see what it gets. And after this round of feedback, the image generator again was delegated a new task to generate a new image with this iterated prompt. Then it generates a new image. And as you can see here, this second image, which is a lot closer to the image that we were giving. But it still have a few disparity. For example, the color of the zipper. So again, it passed on to image reviewer who reviewed the image and give some feedback with iterated prompt. And then passed back to image generator again, who generate a new image. And if we click on that, now it generates a new image with the right color of zips and very similar style to the original image. And after that, it starts a new chat where the user starts a second conversation to the image fine tuner. And as you can see here, it has context part, and this is summary did by the large language model, where it will pass on the latest AI image URL, the original close image, and the latest prompt. The agent returns the image with upscale quality and hand fixed. And if I check the final upscale image, it looks something like this. So I would say this looks pretty good and very close to what the original close image is. And if you want, you can actually add a few new models to the image fine tuner to improve the image even further. This automated image generation pipeline that's powered by ComfyUI and autogen. You can actually build many interesting image generation pipelines for marketing and sales purpose. So I'm really keen to see what kind of interesting use case that you start exploring. And please comment below for any interesting things that you want to see me building. I will continue to share interesting AI projects I'm building. So please subscribe if you want to keep updated. Thank you, and I'll see you next time.